Good afternoon everyone, and welcome to the first part of the three-part series. This video serves as an additional explanatory guide on configuring your own RTK GNSS system. These videos will be accompanied by an applicable hardware article where we delve into the details on how to construct your own custom low-cost RTK GNSS geolocation system. The system is based on the 9th generation ublox F9P receiver, and this is running off a Windows Latte Panda personal computer, so a small Raspberry Pi-like computer, but it is running Windows for software compatibility. So the first part in this video will delve into the details on our own configuration, which works for surveying in your antenna. So this is for the base station or the NTRIP Caster, where we have the antenna in a fixed position. It won't be moved, and we want to very accurately determine the position of the antenna, and we do that using a few software utilities, one being uCenter provided by ublox themselves. So there we will be configuring the various flags of the receiver to ensure that we get the right kind of data and give it the correct type of commands on surveying the antenna in and using the coordinates that we find. There's two ways about the surveying method. The one is a shorter time scale where we can only take a few minutes to get an approximate position of the antenna. This is accurate typically to within 1 meter. For improved accuracy, we can collect what we call raw data readings from the receiver. We'll send that off to a post-processing utility. This improves our accuracy as much as 7 millimeter accuracy in horizontal and vertical, provided of course you have a antenna of decent quality, hopefully supporting multiple band signals. It's just overall better performance. So without further ado, I'm currently remotely dialed into our NTRIP Caster computer installed at the data house adjacent to the N4 highway at the Engineering 4.0 facilities at the University of Pretoria. So in the description and article, you'll find all the software utilities used, so feel free to first read through the content, download all the applicable software utilities, and then resume the video for the instructions. So first things first, I'm opening up uCenter, currently using the newest version available at the time of this recording. So there you can see is the ublox software. So currently we have our GPS receiver module plugged in via USB Type-C in the Latte Panda computer. In order to communicate with the GNSS receiver, we go to the top left over here, and we wish to connect to the applicable COM port or communications port provided by the USB interface. So on our instance, this will be COM port 12. So I'm going to click on COM port 12, and in a moment we should start seeing some activity. So in this viewport, you can see all the various satellites that has been identified or which the antenna is actively receiving data from, along with the strength of the signal. So you'll see it's this particular antenna, which we'll provide the details of as well, receives all 4 major GNSS constellations. That's GPS based in, or rather operated by the USA. We have GLONASS operated by Russia, Galileo operated by the European Union, and then Baidu, if I don't mispronounce that too much, by China. So there you can see all the satellites currently orbiting above the Earth, approximately from Pretoria, where we have our antenna installed. So how exactly do we start configuring our GNSS receiver? We can go to, let's just see here, it's over on View. One of the easiest configuration utilities to work with will be the Messages view, and that's where we set each and every particular flag of the receiver. This provides much more customizability and just a bit more information. And then opening up the second window, we have the configuration view, which is a slightly trimmed down version of the messages view, but it's just a bit more easy to work with. Just to verify that we are in fact receiving data from the GNSS receiver, we can also go to our packet console to see just all the types of messages we are actively receiving at approximately 2 Hz from the receiver, and that's the raw data and the different message types. So prior to the start of this video, I reset the receiver to the default receiver configuration so that your view will be very similar to mine. So what we are interested in is what we call the messages of the antenna receiver. So you'll find it over here under messages, and messages describe what kind of data for a particular satellite constellation is actively provided by the GNSS receiver to the ublox utility program or any other third-party software utility that requires different kinds of messages for specific purposes. So for our working base station or NTRIP configuration, we have to enable a few of these messages that are which are not enabled by default. So first things first, we're going to start looking at the surveying functionality. So one of the most common messages that is normally used and enabled for all instances is the, let me just quickly search for that over here. That is the NMEA messages, and you'll see there's a few types over here: GGA, GLL, GSA, GSV. These are typically, I believe, associated with each of the constellations. If I just click on GGA, you will see that these messages are enabled for all the output ports of the GNSS receiver module. So that's I2C, your 2 UART ports, USB, which is the one we're using, and then SPI. So first, the simple way to survey in our antenna. You'll see on the top right hand corner, this is the approximated position based on the available information of the GNSS receiver. One way in which we can do this surveying is taking the average or the mean of multiple of these readings and minimizing our errors, which can be thought of as a sphere surrounding the receiver, a volume of uncertainty of where exactly that receiver is positioned on the Earth. So for our particular module, we want to configure T mode 3, so that is not under the messages window itself. This is under T mode 3, not T mode 1 or 2, T mode 3. Not sure what the other two time modes are for, but T mode 3 seems to do the job correctly. So there's two options here. The first is to survey in, that is if we do not know the existing coordinate of our antenna, and then we have the fixed mode. So if we already have a coordinate and the module was reset, for example, we can type in the coordinates that we wrote down at some time in the past. So we want to know the exact location of antenna on the Earth. So we go to survey in. We say what's the minimum observation time. This can be anywhere from a few minutes up to a few hours. It is diminishing returns if it's an excessive amount of time. For the purposes of this example, I will make it 3 minutes, so 180 seconds. But I will also specify that the required positional accuracy must be at least 1 meter, irrespective of the minimum observation time. So on the bottom here, there's two commands, send and poll. If I click send, this will send this new configuration to our receiver module. And if I click poll, it will read the current values of that message or the timeout stored within the receiver itself. So with these values set, we want to start our survey in procedure. And I'm going to click send the message to the receiver that we start the survey. So initially you might be thinking that nothing is happening. There's only a little timer ticking there on the top right hand side. What's going on? I don't see any feedback. For that, we go back to our messages window. I'll just expand this ever so slightly. Just minimize all the additional message tabs here that provides a bit of a technical overview. So I'm going to go down to ublox and then nav for navigation, and then it would be SV in, survey in. So the current status of the survey in. So that is under ublox, UBX, navigation submenu, and then within that the SV in. So you'll see it's not always automatically updating the values that you see. If you want to manually see or get a new update of the current survey progress, we can just pull the receiver to receive new data. So it's already about 75 seconds in. You will see that the mean 3D standard deviation is already down to about 1.2 meters. And we will just allow the survey progress to continue until it reaches either 180 seconds and then less than 1 meter standard deviation. The ECEF, or Earth-Centered Earth Fixed Coordinates, are also provided, the equivalent coordinates, and these can be transformed back into latitude, longitude, and height information if desired. ECEF does provide additional flexibility when it comes to calculations, and these can just be stored in a text file for future reference. So with that, let's wait for the receiver to finish the survey in process. And there we go. There is the survey in completed after 225 seconds. We have reached a standard deviation of 0.99 meters. So clearly this was the restrictive controlled criteria until we reached a satisfied solution. So we can copy these coordinates to a text file, and I have already done so with a previous example. Just noting the date and when these values were recorded alongside the typical accuracy that was achieved during the survey in process. So now we know the exact position of the antenna. In order to use this coordinate as part of the RTK functionality, we would have to configure this as a fixed coordinate. So if you go back into the configuration window, again to T mode 3, we can say it's to select the fixed mode, and then we'll enter the coordinates over here. This will be explained in a bit more detail in the second video, as there's additional message options that must be changed or enabled for the RTK functionality to work correctly, together with the provided coordinates, now that we know where that receiver is. Let's say, for example, we want even greater accuracy of the receiver. 1 meter is not good enough for your application. Then we can start recording raw data received from the receiver and send that to a third party for post-processing. So this recording of data typically occurs over quite a longer span of time than the few minutes that we just demonstrated, typically anywhere from 2 to 24 hours if we want that sub-centimeter accuracy. So in order to get the raw output from the antenna itself, we can go back to the configuration window. Just ignore that for now. So then we're going back to messages, and for this we want the raw output, and the flag is also denoted as such in its naming scheme. Let's just have a look at that. So there we go, the RxM raw and raw X. I'm not sure if both are required, but I typically just enable both. So I will enable that for our USB output, the interface that we're using. So I'm going to send through that command. These messages, we can once again go to our packet console under the View tab. And we should see the raw X message or flag here and there in the output. There we see it, just so briefly. So there's all. We have the NMEA messages, we have the ublox raw messages enabled as well. I'm going to close this window, and now we want to record this data stream for post-processing. In order to do that, you'll see there's a record button functionality within uCenter. You can click record. It will now ask us where this file should be saved. For now, I'm just going to select the desktop. We'll use the existing naming scheme with the date and the time, and we will click save. We will say to use the ublox 9th generation, which is that of the receiver. And now we are actively recording data, and you will see that the recording button is still depressed in its current position over there. Once we have collected enough information, which anywhere from 2 to 24 hours, this varies between time constraints, but generally the longer the better. Once we are done recording data for the period of time, we will simply click the eject file button to stop the recordings and ensure that all the data is in fact saved to the file. If we go back into our file explorer, you will see that there is some data that has been recorded in the ublox format. These are examples of previous surveys that were done on this system, and you'll see it's quite a bit bigger at 211 megabytes. And this also represents, I believe, about 6 hours, 6 to 8 hours worth of data. This file format on its own cannot be used to get the precise point positioning. That's the general term, PPP, to get the very accurate location of our receiver. So we're going to use a third-party program called RTK. It's a collection of software utilities specifically catered toward GNSS systems and applications. So from RTK you'll find in the applicable folder there's a utility called RTK CONV, which I believe is short for RTK Convert. This will take this ublox file format and provide us with observation files, and it is this file that will be used in the last step of the post-processing pipeline. So for now, we'll just use a existing file which I recorded, that of 210 megabytes, a bit of a longer time span, and we can specify then where the output of that file should be. So for the sake of simplicity, I'll just record the OBS file that was generated some time ago. And now we can regenerate that observation file from our UBX raw data collection. So once all of this is done, we can also go into the options file to ensure that all the applicable frequencies and constellations have been selected to ensure that we make the most of the data. So for this particular receiver, I've enabled L1, L2 and L5 bands. All the observation types, as well as GPS, GLONASS, Galileo and QZS. I do see that data sometimes pop up on some of the status pages, so I just include that for good measure. Also the approximated XYZ coordinate of our antenna. This can be readily found by just a quick survey in. This just serves as an initial starting point for the optimization software during the post-processing phase. So within 1 or 2 meters, that is good enough. So once we are satisfied with the options, I'm going to click OK. And then finally, we can convert that UBX data file into observation files. And there you'll see a number of observations, and it's relatively quick to do these conversions. And that time refers to the local time at which this data was recorded. And there we can see the observation file that was generated from our ublox raw measurements. Once we have the observation file, we are ready to submit that to our third-party post-processing application. For this, I'm opening up an internet browser. And we will be using the Canadian Geodetic Survey. This is a free service to convert that observation file, process it, and then get your accurate coordinate where your antenna receiver is. For this, you will need to create an account, which is again also free. So I'll just log back into my account. And the service is generally very quick. Within 10 to 15 minutes, you will receive an emailed report back from this service giving you summary statistics of your observations. So let's just give that a moment. So there we go, not too many controls. So typically we will select static because the antenna remains static. We will select the international reference frame option. The vertical datum, I typically just leave that as is. Nothing to select over here in terms of having marker stations. And then finally, we want to choose our file. Note that it's a 300 megabyte limit. You can also zip this file together with other files or just zip it on its own for quicker upload time. So then we will go to choose file. Opens up the File Explorer window. And then we will select the OBS file. We would click open and then submit to PPP, which I'm not going to do this in this step. Once you submit that file, it will just show you a completion message, and then you just wait for the results. So what do these results typically look like? I've got an example over here. So there you can see it's a complete PDF file. And if we scroll down a little bit, you will see the duration of the observations, when the data was started and when it ended. And for this particular observation data set, the post-processing was done more than 2 weeks after data collection to ensure the most accurate results due to the improved accuracy with which the orbits of the GNSS satellites can be determined as time goes on. And here you will see that we get about 7 to 9 millimeter accuracy on a horizontal plane, the latitude and the longitude, and 34 millimeter accuracy in the vertical. So using these coordinates, they can either be transformed back into ECEF coordinates, or they can be adapted just in the current form with decimal places. And we can then go back to ublox, back to our configuration window, back to our time mode 3, and then we can say fixed mode and copy and paste those values in here using either ECEF or latitude, longitude, and altitude information. So after 2 weeks of recording data, submit it for post-processing, and then if all goes well, you will have very, very accurate positional information of your receiver station. So this is the end of the first part of the video series. In the second part, we'll be looking at our working configuration example of the base station working in RTK mode, and how we get these corrections sent to the server that we can ultimately use in the field with our rover. So see you in the next video.